Okay, so today we're going to continue with the geometry side of stuff. We've been looking at angles and a little bit at triangles and stuff like that. We started out talking about, or last class we ended up talking about finding missing sides of triangles, or the right triangles, let's say where the legs are A and B and the hypotenuse is C. Now use that A squared plus B squared equals C squared. One of the things we're going to discuss today is called perimeter. Perimeter is the distance around an object. And we've seen formulas for perimeters for rectangles and stuff like that before. But perimeter is really simple. It's just adding up the sides. So let's say that this figure here is 8 inches on this side, 21 inches here, 18 inches here, and 25 inches there. The perimeter is found by just adding them up. 8 plus 21 plus 18 plus 25. We add those all up, we're going to get 46, 54, 72 inches is our perimeter. So it's just a matter of adding up those sides. You know, we found with rectangles and squares there are going to be some shortcuts. Morning. So if we have a rectangle, pretend that actually looks like a rectangle. It's 8 inches on one side, 17 inches on the other. We know that this side is going to be 8 inches and this one's 17 as well. Because a rectangle, opposite sides are always equal. In fact, it doesn't even have to be a rectangle. This one, to make it a rectangle, I'd have to indicate at least one of the corners is a right angle. But it could just be a parallelogram. Opposite sides of a parallelogram are still the same, even though it doesn't have the right angles. So this one might be 7 inches and 15 inches. 7 and 15. And this next formula for perimeter, I mean, we can always just add up all the sides, just like we did up here for this one. We just added up all the individual sides. But there's a shortcut here. Since the sides come in pairs, we can just do 2 times the 17 plus 2 times the 8. Or over here, 2 times the 15 plus 2 times the 7. Morning. I'll go ahead and finish this one off. 2 times 17 is 34. 2 times 8 is 16, which adds up to 50. So that perimeter there is 50 inches.
Is that the formula for P equals
2L plus 2W? Yes.
So what did you know that test that I did it right, but I put the wrong answer down when it asked for the perimeter, but I times it by 2?
You multiplied it by 2 after you found it.
What?
We were looking for we gave you the length and we were looking for the width, I believe.
Yeah.
And you found 2W. You found W, but then you multiplied it by 2. You're not supposed to. It's just W, yes. So this one over here, 2 times 15 is 30. 2 times 7 is 14. That adds up to 44 inches. So perimeter is pretty simple. If we have straight sides, all you have to do is add up the lengths of the sides, no matter how many there are. If you have sides that are repeated, like there are here, this side appears twice, so I can just do 2 times that, so I don't have to add them in as many times. When we have a circle, it gets a little more complex. Depending on how you look at it, a circle either has no sides to add up, or a circle has just one side, depending on how you look at it. To find the perimeter of a circle, so for a circle, as I said, either there are no sides to deal with or there's only one side, depending on how you look at it. The perimeter of a circle is called a circumference. It's found because in fact, they developed it a couple thousand years ago. There's a ratio between the circumference of a circle divided by the diameter of a circle. The diameter of a circle is the distance across. It's a chord that goes through the center. That's a diameter. That ratio comes out to be a number. It's actually 3.1415926. They call it pi. We're just going to say it's approximately equal to 3.14. That's what we're going to use for it. It's 3.14. My math lab will specify what it wants. It might sometimes say 3.14. I don't know if I used any in any of your assignments, but sometimes it does ask for 3.1415 for pi. So make sure you read the problem carefully. It'll tell you what it wants you to use for pi. Now your calculator does have a pi key on it, which is just fine. But in my math lab, using that key, it might round different than if you just use 3.14. So be aware of that. If it tells you it's wrong and you're really close, let me know and I'll fix that. It's just because you used the pi key and my math lab used a different one. No, it does not. At least as far as we know, it does not. They've taken it out to like 20,000 digits. So because that ratio between the circumference and the diameter is pi, you can find the circumference, we just abbreviate it with C, is pi times the diameter of a circle. So if I have a circle, it has a diameter of 8 inches. Find the circumference or the perimeter. The circumference is pi times 8 inches, which is 25.12 inches. 3.14 times 8. If I have a circle, it looks like this, and I tell you that this here is 5 inches. What I gave you there is not a circumference. What's that called? That's called a radius. Sorry, it's not a diameter, it's a radius. We need the diameter. How do you find the diameter from the radius? Twice the radius, right? 2 times the radius. So if the radius is 5, 2 times 5 is 10 inches for the diameter. So then the circumference is pi times 10. So 3.14 times 10, or 31.4 inches. Circumference is pi times diameter. Now, since the diameter is equal to, or 2 times the radius, there is an alternative formula for circumference. We have this one. Some books say circumference is 2 times pi times the radius, because 2 times the radius is equal to the diameter. You get the same answer, yeah. Here I did, 2 times 5 to get the diameter of 10, and then I used that in the formula. I could have done 2 times pi times 5, but it still gives me 3.4, or 31.4. Same answer I got before. Area we've talked about briefly before. Area, and we took that point and we moved it in a single direction to create a length. It was one dimensional now. We moved it in one direction. We now have one dimension. If I take that area and I move it in a second direction, it now creates an area. The size of that area depends on two things. It depends on the length of that original line, and then the distance we moved it. That distance we moved it is often called a width. So for a rectangle, area is length times width. So if this is 18 feet here and 7 feet here, that area is going to be 18 feet times 7 feet. Is that 126 feet? 126. Of course, feet times feet is feet squared. Now this was a rectangle. I didn't draw in the right angle, but I told you it was a rectangle. It does not have to be a rectangle to find its area. But to find area, we do have to use two dimensions that are perpendicular. So I might be told that this up here is, oh, let's say that I tell you this is 10 feet. And I tell you this is 10 feet. I cannot do the area as 10 by 10 because those they don't form a right angle with each other. They're not perpendicular. If I knew this dimension here, however, I could find it. If I tell you that this across here is 6 feet, I can now find this length here. Because what I have here now is a right triangle. And in a right triangle, these are the legs. I'll call this A, B, and C. We learned last class A squared plus B squared equals C squared. So we have 6 squared plus B squared equals 10 squared. And we solve. 6 squared is 36. 10 squared is 100. We subtract the 36. So we have B squared is 64. And finally, we square root. B is 8. So this is 8 feet here. So the area of that is 10 feet times 8 feet, or 80 square feet. No, that's the whole thing. Because basically what you're doing is you're saying this. I'm going to take this triangle here, and I'm going to cut it off, and I'll move it over here. And so now what I have, if I'd have drawn this well, is this right here is now a rectangle. It's 8 by 10. How about a circle? Anybody remember the formula for the area of a circle? It involves pi again. It's pi times radius squared. Now I'm going to show you where that formula comes from. The circumference of this circle, if the radius, I'm just going to call the radius r for now, is 2 times pi times radius, right? That's the distance all the way around. Just our formula. Well, if I cut this circle in half, and I just look at this half of the circle, what's the distance? Come on. What's the distance around this half of the circle? It's half the circumference, isn't it? If I divide that by 2, what do I get? Well, the 2's cancel out. That's just pi times radius. So here's what I'm going to do. I'm going to take that half circle, I'm going to cut it into really thin like pie wedges, pie slices. Then I'm going to fan those slices out. Like that. If I cut them thin enough, this distance across here is just pi times radius, pi r. Half of the circumference of that circle. Well, there's still another half of this circle here. If I take that other half of the circle and I cut it into equally thin pie slices, I can fan those out and fill in the gaps here. Now, like I said, if I cut those slices thin enough, what I've created here is a rectangle. The length of that rectangle is pi times r. What's the width here? What's this distance? Well, that's just this, which is what? The radius of the circle. So I've created a rectangle that's pi times r, which is pi r squared. So that's where the formula for the area of a circle comes from. I don't expect you to know what I just showed you how to derive that formula, but I do expect you to know that to find the area of a circle, we have to do pi r squared. So if I give you a circle with a radius of 5 feet, to find its area, it is pi times 5 feet squared. So I just punch that in the calculator, 3.14 times 5 squared. Should give us 78.5 about. So it's 78.5 square feet. Or if I give you a circle, and I tell you that the diameter of this circle is 4 inches. How do I find the area? Pi times what? Not 4 squared, but 2 squared. Because 4 is the diameter. We want radius. The radius would be 2, half of the diameter. So it should be 12.56. That's in inches, so that's inches squared. Does that make sense? Sort of? Kind of? Okay. Everybody seems really high energy today. I'm out of it today too for some reason. I'm tired. I don't know if it's the weather or what it is. I could very easily go lay down and take a nap. So it might be that my voice just doesn't have the energy in it today that it normally does. I don't know. I'll take the blame.
So is the homework that's due at 1 and this stuff on?
No. The homework that's due at 1 is from Monday's stuff. The angles and the triangles and roots and squares and Pythagorean theorem. Let's see. Let's see. We have something like this. I tell you the distance across here. I tell you it's a perfect half circle. The distance across here is 40 inches. Want to find its perimeter? Want to find its area? To do either one, I'm going to have to pretend that it's a full circle. For the perimeter, the circumference of that full circle would be found by doing what? Pi times diameter. So for this one, that's going to be pi is 40 the diameter. Say yes. So it's 125.6 inches. That would be the circumference of the whole circle. But we don't have a full circle. We've only got half of a circle, right? Divided by 2, which is going to be 62.8 inches. Is that my perimeter of the figure? Well, that is this length here. What do I still need? Yeah, that 40 inches there. So that's 102.8 inches of perimeter. Area do the same type of thing. Area is pi times radius squared. So that's going to be pi times, not 40, 20 squared. The radius will be half of the 40, it would just be 20 inches. Pi times 20 squared is 1,256 inches squared. But that would be, again, for the whole circle, we need to do what? Divide that by 2, because we only have half a circle. So that's going to be 628 inches squared. That's the area. Well, that's not so bad, is it? Sure. That little symbol, that little cross there means it's the center of the circle, which is indicating that each of those is a half circle. If I tell you that this full distance across here is 100 feet, this distance across here is 40 feet. I want to find perimeter. And I want to find the area. Well, the perimeter, remember, perimeter, I just add up sides. How long is this side here? Well, no, 100 goes all the way out to the ends. What is the radius of this half circle? Yeah, the whole diameter is 40. So half that is going to be 20 feet. So that means from here to here has to be 20 feet. And here to here has to be 20 feet. So 60. That piece is 60 feet. So that's 60 plus this one up here is also 60. What pieces do I still need to add in? I need this half circle here, don't I? And this half circle here, don't I? So to find that half circle, I'm going to find the circumference of the full circle, which is pi times diameter, pi times 40, which would be 125.6 feet. Now that would be a full circle. If I just wanted this piece here, I'd divide that by 2, wouldn't I? Because it's half a circle. But here's the thing. I've got half a circle over here. I got half a circle over here, which makes a full circle. So I just have 2 half circles. So I don't need to divide that in half. I have 1 full circle between the 2 pieces. Does that make sense? So I have 125.6 feet. That's both of these 2 pieces put together. So that adds up to 245.6 feet of perimeter. Notice perimeter is a length, so it's just feet or inches or millimeters or centimeters. It's just a length. Area, well, I have 3 sections to worry about here. I have this rectangle in the middle. Then I have these 2 half circles to worry about. How do I find the area of the rectangle in the middle? Length times width, 60 times 40. So for piece 1, it's just going to be 60 feet times 40 feet, which is 2,400 square feet. Bless you. For pieces 2 and 3, I'm going to do the same thing again. I can put those two half circles together to make one full circle, and it has a radius of 20 feet. So the area is pi times 20 squared, otherwise known as 1256, right? If I use 3.14 as pi, feet squared. So that adds up to 3,656 square feet for my total area. So really the only trick to these is cutting them up into pieces that we know how to find. Right now we know how to find circles, we know how to find rectangles, find the area of a triangle. Let's say that this is 12 inches here and 9 inches here. Well, since that's got a right angle, I'm using a right triangle. I can think of it as being a rectangle like that. What would the area of that rectangle be? 12 inches times 9 inches, right? But we cut the rectangle in half. So to find the area of the triangle, we divide that by 2. So 12 times 9 is 104, divided by 2 is 54 inches squared is the area of that triangle. So triangles, length times width, or base times height, divided by 2, however you want to look at it. Let's say that's 24 inches. This is 20 inches. 6 inches and 6 inches. If I want to find its area, the perimeter actually is just going to end up being 88 inches, just adding up the sides. If I want to find its area, first of all, I should probably find the missing sides. What would this side be? Careful. It ends up being 14. Because this whole distance across here is the 20, right? And this piece here is 6. So 20 minus 6 is 14. And same type of thing here. This whole distance is 24. This missing piece is 6, so this distance is what? 18 inches, not feet. So to find perimeter, I am just going to add up those 6 sides. It comes to be 88 inches. For area, there's 2 possibilities. I can chop it into smaller pieces and add. Now, there's a couple of different ways I can chop this into smaller pieces. I could chop it across here and have a rectangle on top and one on bottom. Or I could have chopped it down this way and had a rectangle on the left and one on the right. I'm going to chop it sideways like this. That top rectangle is 14 by 6, which is 84 inches squared. This bottom rectangle, rectangle 2, is 20 by 18. So 360 inches squared. If we add those up, we get 444 inches squared is our area. The other option, that was chopping and adding. The other option was we could find a larger area and subtract. So what do I mean by that? I mean I could have done this. Could have put that, filled in that corner, so this is now 24 by 20. So that larger area is 24 by 20. 480 square inches. And then subtract out this corner here that's missing. It's 6 by 6. Well, 6 times 6 is 36 square inches. We subtract that out. Get the same result. We better get the same result either way, right? Otherwise, I did at least one of them wrong. So this problem here is it's almost exactly the same amount of effort to do it either way. But we're going to run into problems that have to be done one way or another. For example, let me alter this problem just a little bit. This time, instead of chopping out a corner here that's 6 by 6, I'm going to make that corner a half circle. I'm not going to tell you it's 6 by 6. I'm going to tell you this side here is 24. This side here is 20. And from here to here is 18. Now, if that's 18, what does this distance have to be? 6. Has to add up 24. So that means this distance here is 6. What's this distance have to be? Has to be 6. It's a radius. If this is a circle, piece of a circle here, radius has to be the same no matter what direction. So if I know the vertical, the horizontal has to be the same because they're both radii of that circle. So then, of course, that tells me that up here, this is 14. The 20 minus the 6. This one, I would not be able to do this. I would not be able to extend that out and subtract out the missing piece. That would not work. For this one, I would have to chop it up. Probably chop it up like that. So I have piece 1, 2, and 3. Well, piece 1 we've already found. That is a 14-inch by 6-inch rectangle, which is going to be 84 inches squared. Piece 2 here we've already found. It's a 20-inch by 18-inch rectangle. Let's see, at 360 square inches. Piece 3 we have not found yet. That's going to be pi times 6 squared. That would be this whole circle here. What do I have to do to it, though? Divide by 4. Why 4? It's only a fourth of a circle. So this pi is 3.14 times 6 squared divided by 4. 28.26. We add those all up to 472.26 inches squared. What do you think? Okay. There might be other ones. Pretend that looks like a half circle. Or we have something like this, where I want to find the area of this. This one I could not add together pieces. Here I have to find the large rectangle and subtract out the half circle. So that large rectangle is 20 feet by 10 feet, which is 200 square feet. That half circle that's missing is pi times what? It's not going to be 10. It's going to be the radius. 10 is the diameter. The radius will be 5, right? Pi times 5 squared. Divided by 2. Did everybody see where the 5 came from? Any questions on where the 5 came from? Yeah, 10 goes all the way across. 10 is the diameter. So half of that is 5 is the radius. Yep. Radius is always half the diameter. And to find area, you have to have the radius. And since it's half a circle, we're going to divide it by 2. 39.25. We will subtract. That's going to be 160.75 square feet. Questions? The visual. And there are a lot of people that do struggle with the shapes. The 39, it was pi 3.14, yep, times 5 squared, and then divided by 2. And then since that's technically a piece that's missing, that's why we had to subtract it. Let's talk about volume. Volume is the next step. So let's say we have this area. This here is a rectangle. We're just viewing it from kind of up and off at an angle. So let's say that this is 15 inches by 8 inches. That rectangle has an area of 15 inches by 8 inches, or 120 square inches. If I want to create a volume, just like we created an area by taking that line segment, that length, and moving it, to create a volume, we're going to take this area and move it. Like that. We create a box or a solid object. That solid object has volume. The piece that we started with, that we moved to create this object, is called a base. A volume is defined to be an area of a base times that distance that it's moved. In most cases, that distance is referred to as a height. But it doesn't always go up and down. So the tough part is figuring out what piece of it is a base when we're looking at an object. If I have a box, now for those of you that are struggling to draw the box like what I did up there, here's a little trick. Draw a rectangle, then just draw another rectangle the same size that's slightly off, connect the corners. You have a box. On this box, I could use any of the sides as a base. I could take the bottom piece here, and I could think of as I took that bottom piece and I moved that. You see, I would move that to make slide that through space to make the object. Or I could have taken this end piece here. I could have moved that through space to create that object. Could have taken the front piece. So when I'm dealing with a box like this where all the sides are rectangles, any of the sides could really be the base. So just to make it simple, we're going to use the bottom as the base. It won't always be the bottom. I'll show you a figure in my next example where it's not the bottom for the base. So let's say that this side here is 15 inches, this over here is 6 inches, and this is 10 inches. To find the volume, first step we're going to do is find the area of the base. The area of the base is just a rectangle. It's 15 inches by 6 inches. 15 by 6 makes 90 inches squared. So that's the area of that base. My volume is then that area of the base, 90 inches squared, times the height of 10 inches. So that's 900 inches squared times inches is inches cubed, or cubic inches. Now there we had a box where, like we said, any side of it could be the base, so we just use the bottom. But it will not always be the bottom that is the base. We could have a shape like this. Here, the base has to be this triangle here. That's the shape that I moved through space to create this object. Does that make sense? So I have to give you some dimensions. Let's say that this is 12 inches, 5 inches, and 20 inches. So to find the volume here, I start out by finding the area of the base. Now this base is a triangle. So it's base times height divided by 2. Or sometimes 1/2 times base times height, which is going to be 30 inches squared. That's the area of that base. So that I find my volume by taking the area of the base times what in this picture? The 20. So 30 inches squared times 20 inches is 600 inches cubed. Any questions? Well, if it's a box, like I said, I could use any side, so I just use the bottom. Technically, when it's a box, I can just do, if I really wanted to, I can do length times width times height. So I could just do 15 times 6 times 10. That's going to give me 900. But I want to be consistent because not every shape we're going to deal with is going to be a box. So it is just length times width is just the area of the base, then times the height. If you can't tell what the base is, the best guess is always the bottom of it. But like this one here, the bottom, if I looked at the bottom of it, I can't take that bottom and slide it through the object. It just doesn't fit. So the bottom cannot be the base. This end is the only piece that slides through the whole object. Okay. There's only a few minutes left, so I'm not going to try to put anything new in here. We are going to talk more about volumes tomorrow and a little bit about surface areas. There is new homework due for Monday. Again, we'll talk more about that tomorrow. There is a new quiz. This quiz is on the stuff from Monday's class that is due tomorrow. That'll be Thursday at 11:59 p.m. You look like you're not really happy about this stuff. Geometry's not your thing? Hang in there. We'll do what we can to help you out with it. It's all about seeing patterns, like I said.